Let's take a look at an important example. The example where our sequence consists of basically taking a number r and raising it to the nth power. So the first thing I want to mention is that r is a constant. So this guy is a constant. Okay. And we have really actually began the course by looking at exponential functions. So let me take a moment to graph a couple of exponential functions for you. Hold on one moment. And voila, we have two graphs here. Now, both of these graphs are graphs of exponential functions. In other words, this graph on the left is y is equal to b to the x power. But in this case, our b is greater than 1. This graph on the right is also y equal to b to the x power. But this graph corresponds to the case where our base is going to be between 0 and 1. Okay, so what can we see about each of these graphs as we take a limit as n goes to infinity? We could say as n goes to infinity, b to the n is going to go to positive infinity. In other words, it's going to diverge. Okay, what about the situation on the right? As n goes to infinity, b to the n is going to go to 0. So this is the situation where it converges. Now, one thing you'll notice is that my graph has x, but when I looked at my sequence, I used n. The difference here is that n is an integer. So these are like points that live on this curve. Whereas when I think about it as a graph in terms of x, this is a continuous function with all the points in between consecutive points being filled in. Okay. And what we want to do is we basically want to use these graphs to really think of a case-by-case analysis. So we're really basically saying, what is the limit as n goes to infinity of r to the n going to be? And we're going to break this down for different values of r. So from the example on the left, we could say that this is going to be infinity if r is greater than 1. Because really, the role of r is being played by b. Let's take a look at the next scenario. So let's say that we're going to look at absolute value of r being less than 1. In other words, if I drew a number line and, I labeled the 0 in the middle, I have a 1 here, and I have a negative 1 over here. Clearly, when r is equal to 0, it's going to converge to 0 because 0 to the nth power is going to be 0. What happens if I'm in between 0 and 1? If I'm in between 0 and 1, we just showed on the left side over here that for values between 0 and 1, our function's going to go to 0 as well. What happens if I'm between negative 1 and 0? If I'm between negative 1 and 0, we basically have the same graph over here, but with a negative in front. So that's going to be a vertical reflection. And even if I flip it across the y-axis, the x-axis, it's still going to go to 0. So I hope I've convinced you that when the absolute value of r is strictly less than 1, we're still going to get our sequence r to the n going to 0. So then I think the final thing we really need to worry about is what about at the two endpoints, negative 1 and 1? Let's look at the case where r is equal to 1 first. So we're looking at the right endpoint over here. So if r is equal to 1, what does our sequence look like? Well, the first term of the sequence will be 1 to the first power, which is 1. The second term of the sequence will be 1 to the second power, which is 1, to the third power, which is 1, and so on and so forth. So I hope I've convinced you that when r is equal to 1, 1 to the n is just going to go to 1. What about the left endpoint over here? In other words, let's take a look and see what happens when r is equal to negative 1. When r is equal to negative 1, so if r is equal to negative 1, what does our sequence look like? Well, the first term is going to be negative 1, because negative 1 to the first power is 1. The second term is going to be 1. Negative 1 squared is 1. The third term is going to be negative 1, because negative 1 cubed is negative 1. And then the negative 1 to the fourth is 1, and so on and so forth. So this guy keeps alternating between negative 1 and 1. Okay, so that situation is when we say this limit does not exist. So this diverges. All right, so if I were to try to sum all of this up into a picture, I would write it like this. I would say r to the n converges if your r is inside the half open interval from negative 1 to the half closed part, which is 1 like this. And we can even draw a number line to illustrate this fact here. So we've got our negative 1 like this and our 1 like this. I'm going to put an open circle to indicate I don't want to include negative 1. And I put a closed circle here to indicate that I do want to include negative 1. And any number in between, for any r in between there, that sequence is going to converge. So I'm going to highlight this result because it is something that's important to us, which we will use in the not so distant future. All right, everybody, that's it for this example. Take care.